Yes, my name is Mikhail. It's Mr. Pulumi, yeah, these days. So thank you, Henry. That was a great introduction to my talk, because I don't have to explain why you don't have to click in the portal and what's infrastructure as code and why it's good. So let's imagine you agree with him and you actually went home and applied all those best practices, and now maybe you are not quite satisfied with what you got in the end. So I actually have my own experience with ARM templates, and that's where I started. I think it was 2 years ago. We had a project, so we worked in like small company and DevOps team, developers, operations working together, shipping stuff to production, and we were moving our applications from on-premises to Azure Cloud. So it was like a web server and a database, and then boom, lots of stuff in Azure: queues, databases, storage, functions, app services, and so on and so forth. And we try to do it like properly, do automated testing, pipelines, CI/CD, and infrastructure as code with ARM templates. And we had several applications, but I remember for one application we had about 5,000 lines of JSON to deploy it. And it wasn't like super complicated application, just those components. And the process of authoring this used to be quite more painful than what Henry showed, because there was no VS Code plugin that would work. So for us, it usually would be Googling something, copy-pasting the snippet, insert it into the editor, then run the deployment. It says running for 5 minutes, and then it spills off some error, which is usually cryptic. And then you fix something, try again, and go on and go on, and until you get 5,000 lines of JSON. Yes, once it works reliably and like to that all the points in one bullet. That's fine. So I thought there should be maybe a better way which would resemble more to how I do application development, but also for infrastructure. So I started using first for my personal projects a tool called Pulumi. I started as a user, deployment stuff to Azure. Then I met a guy. I started contributing because it's all open source and on GitHub. And then eventually, since last November, I work in a company called Pulumi. So now I work on a tool which deploys stuff to the cloud. And then my production is sort of you sitting here. That's why I go here and like talk to people, so to make sure that it makes sense, kind of. So more formal introduction. My name is Mikhail. I work at Pulumi as a software engineer. I work on many stuff. It's a startup. Everybody does everything. But in particular, I'm focused on Azure SDK and .NET SDK. And besides that, I love serverless, so Azure Functions, AWS Lambda, functional programming with FSharp. Let's chat about this afterwards. Doesn't really matter. So the agenda, because our tool works not only for Azure, I also touch on other clouds, particularly AWS. Anybody using AWS here? Couple people, okay. And then I'll start like from other tools as well, mention infrastructure as code tools for those. And then the main part is about Pulumi, of course. So cloud automation, Henry gave you all the right introduction. We have the great layers. That's common for every cloud, very similar picture. Whatever tool you use to create your resources, you in the end talk to some REST API in Azure, AWS, anywhere. So the first way to automate is just make REST calls. You write them in Postman or curl or whatever. That works, but it's very low level. So every cloud also has SDKs for all major languages, including .NET, but also Java, Python, Node.js, and so on. You write sort of, instead of JSON, you write normal C# code, but it's the same level of abstraction. So every time, say you say EC2 run instances, it will go ahead and make that call to REST API, parse the response, and then give you a class back. Right? But the experience is much more familiar to developers. If you are more operation guy, you will use command line tools, which is sort of the same sending requests and getting responses back, but from command line. So there are quite some challenges with this approach. It works, but not that great. First, it's very imperative because you have to describe exactly the steps to get to the desired state, right? You don't describe what you want, you describe the steps to go through. Then, because you have multiple environments and they are sort of similar but also different at the same time, you start customizing them, making something like if statements here and there. And also your environments live for many months or years, so you end up with a lot of update scripts instead of just one thing, like one ARM template. And that's quite complex to manage. So also if your script fails somewhere in between, you usually don't know like what's the current state of your infrastructure. Can you run it again and then it would succeed, or would it create duplicate resources, or like it's hard to test this once and forever. So for many years there is a notion of desired state configuration, also applies to ARM templates. So instead of describing the steps how to get there, you describe the target state. And then the tool takes care of comparing the target state that you describe with any possible current state that you currently have, and then figuring out the mechanics of how to bring the current state to the target. So you manage one thing, and then the tool can sort of automate the rest. A useful way to look at this is to describe those states as graphs of resources. So every resource is a node, and then edges are dependencies between the nodes, because that's important in order to figure out the right deployment process. And you saw dependency management in our templates with depends on. Still, those tools are quite complicated to create them. There are multiple aspects to this. First, they have to be expressive enough for you to be able actually to define the target state, and ideally in a small, concise way and a correct way. Then, because of multiple, like numerous permutations of current states and target states, the tool should be quite sophisticated to be able to bring any current state to any target state. So that's a very complex thing to solve in general. And then, because of those two complexities, it should also be transparent about how it works. So before you make any changes, ideally you should see like what it's about to make, predict the changes, and then stop it if it, say, tries to delete your SQL database because you changed the name accidentally. Every cloud vendor has their own tool. ARM templates, but also CloudFormation for AWS, a deployment manager for Google. They all very specific to their clouds, but they also are very similar on high level. They all use markup languages. So either JSON or YAML or both. That's the same example that Henry showed. That's ARM template with JSON. This is CloudFormation. They started with JSON, but now it's YAML these days, mostly. And you can see that they also have their own way to express stuff inside YAML. So it's not really YAML, it's a DSL embedded into YAML. You know how to make references between resources. There is like if statements there with special syntax. And every tool has their own way to do the same things. Also, there are third-party tools. The most known one, Terraform. Anybody using Terraform? No? Okay. But it's a tool from HashiCorp. It's open source. It works for multiple clouds. And they actually invented their own language to define configuration, HashiCorp configuration language. It's still a markup, but sort of simplified JSON with a more expressive way to do things like references. But still that's a markup, still that's a text. And any markup language like that has a set of challenges. First, the tooling basically starts from scratch. You see some advances with ARM templates, but they are sort of recent. When you just start, you have your raw YAML or raw JSON, and go ahead, just edit that text. So creating huge files from scratch is quite complicated. It's either snippets or copy-pasting from Stack Overflow or copy-pasting from Azure Portal. Like it's hard to sit down in a notepad and write it, or well, not even notepad, VS Code or something. And the size, of course, is a problem. I alluded to this in my introduction of 5,000 lines. It gets big quite fast because it's very low level. It's on like the basic level of cloud resources. Simple example, I love serverless functions, so I do everything with them. I wrote like a very simple application, which is URL shortener. You go to one URL. Yes, everybody does that. But that's cool because like you can find online all the examples in any kind of technology doing that, and then you can compare. So it just takes URL, looks up in the database like DynamoDB or Cosmos DB, and if it's there, it redirects you to the different URL. 20 lines of code, this JavaScript in this case, but could be C#, and then around 200 lines of resources because you need API gateways, lambdas, dynamos, permissions, deployments, or in Azure functions, Cosmos, whatnot, storage accounts, storage containers, blobs, and so on and so forth. So this doesn't feel right. You write 20 lines of code and then 200 lines of YAML. Yes?
What do you define as a line of code in ARM templates though? Because it's just one massive JSON.
Every line.
I never want to read your JSON files.
Do you just concatenate everything in one line? Okay. I mean, if you pretty format it with JSON standard. Yes. So the idea is that instead we could just take the developer tools like IDEs, functions, compilers, IntelliSense, package managers, and so on, and start writing infrastructure with those tools as we are used to for applications. So that's the introduction to Pulumi. The idea is that you manage your infrastructure as with ARM templates, but instead of ARM templates, you can use languages. Currently, 4 runtimes are supported: Node.js, Python, Go, and .NET. So any .NET language that you love, C#, I love FSharp, maybe somebody Visual Basic, or even PowerShell could be used. So honestly, we started with Node.js, then Python, then Go, then .NET. So .NET is still in preview. It's going to be released in April. But the biggest missing thing is that nice kind of documentation that exists for ARM templates. It doesn't exist here, basically. That's the biggest missing part. But we are working on it. I'll touch on that, how it's going to work. Cool thing that we support multiple clouds, not just Azure. You can do AWS, GCP, Azure, but also things like DigitalOcean, Cloudflare, Kubernetes. It's also stuff that is not really cloud, even things like Postgres or Oracle, tables, New Relic, monitoring. We have like 40 at the moment. Basically anything that can be modeled as something creating resources can be a provider. Finally, some code example. This is for Azure. It creates 2 resources: a resource group, which is also a resource, and a storage account. So this is just creating objects in C#. First object gets a parameter name, and storage account gets a name and some property back, and 2 of them are just properties, and then the third one is a resource group name. And because we used variable resource group to define it, the tool will already understand that there is a dependency between them. So we don't have to declare it explicitly. Just because you used a variable, there is a link there. So the most important thing to understand about this is that this is still desired state configuration management tool. So this is not like C# SDK for Azure, where you imperatively write commands. This defines the graph of resources in Azure, your target configuration. You change it only when so you append to it when it grows, for example, or change one property if you want to change in one place. When this code runs, actually nothing is created in Azure automatically. The graph is created in memory, like the definition of resources. And then there is another component which knows how to interpret that and compare it with the previous one. So the deployment sort of, like the logical diagram here, is that we have language first at the bottom. It's specific per runtime. It knows how to interpret your programs. In our case, it will do .NET build, .NET run for your C# project. I'm going to show this in a second. And then it builds the graph definition. Okay? And then it passes this graph definition to the smart guy, command line interface, engine, whatever you call it. It's a thin binary you install on your machine. And that thing compares your target state with previous history of current state of the environment. If we run it the first time, the current state is empty. So it will figure out it needs to create a resource group, and because of the dependency, after it's created, then storage account. So it sends the command to Azure, create a resource group, and then storage account. Yes?
I have a question. You say last deployed state. Is that the actual state, or is that...
I'll explain later.
Thank you.
Yeah, no problem. And then you deploy it the first time, then maybe you change something in storage account, and then it compares it with previous two resources, figures out it needs to say delete the old storage account to create a new one. Things like that. So to make it more visual, I will show how it works with AWS in this example, but it's going to be Azure later. So I have a demo project which deploys a static website to S3. S3 like storage account, storage container in Azure. This is a C# project, just SDK, normal CS Proj, .NET Core 3.1. I referenced two NuGet packages. You can see they are still in preview. The core one, and then the one to work with AWS. And I can reference other stuff if I need to. It's just a C# project. Then there is program.cs, very simple. It's a console application with main method. All it does, it calls Pulumi deployment run async and passes a generic parameter. And well, in theory, you could do anything here. You can load configuration files, do dependency injection, I don't know, call a web service, whatever you wish. And then all this stuff is actually here in static website. And this is a class derived from stack. Stack is like a virtual container for one deployment, like deployment object in Azure, sort of. Yeah, maybe. And then it has a constructor, and then I start creating the resources. So this statement would create a bucket, like a storage container in Azure, with a name, and then I say I want a website from it, and the root document is this. And then on my disk I have root folder with 2 files, I think. And this is just a C#, so I can do whatever I want. I can call standard library to get a list of files. I can iterate for them with for each. I can do things like, I don't know, substring, get MIME types to understand what kind of type it is, file it is. And then finally, for every file inside a loop, I create a big bucket object. It's a public file. In that bucket, that's the dependency link. And then just to show you, like, that's just C# code in your favorite IDE. I'm using Rider. But you can say, I don't know, that's environment, production. So you can see that you get IntelliSense, you get compiler errors if you type something wrong, hopefully, yes. So very fast feedback loop, you don't have to run it before you actually sort of validate it in the first place. And then finally, because I don't know the URL of the website, it's going to be assigned by AWS themselves. I need to export it, so that's like output from our template. I need to create a property called whatever I want, endpoint, mark it with attribute, and then assign it with a formatable string from what Azure or AWS offers, and then HTTP. So that's a program. I hope I saved it. I go to CLI now, so that I have to run it from CLI. I cannot like F5 in Visual Studio. If I do that, I just get the graph definition. I don't get the deployment. And I want to deploy this. So I have Pulumi installed on my machine, obviously. And I have to say Pulumi up. That's cross-platform, macOS, Windows, Linux, whatever. You can run it from Azure Cloud Shell. So go to Cloud Shell, write a small command to install it, and then it works there. And then what I get is the preview of what's about to be deployed. That's a new environment, so it says stack is like nothing actually in AWS. The namespace is Pulumi, so it's a virtual thing. And then 3 AWS resources, bucket object for my files. If I'm happy, I can say yes. So until up to this point, nothing was deployed yet. It's just a preview. And now it runs the program again, gets the graph definition again, and then this time, every time it gets something from that graph, it starts deploying it, and in the end, I get 3 resources deployed and a URL. If I click, I see my file over there. It's a static website on Amazon Web Services. Now, let's say I want to change something. This was actually not production, but staging. And then maybe I'll go to make it a bit more interesting and rename a file from, I have company.html, now I will rename it to, I don't know, about. Doesn't matter. And now I can run the same command again. And because it knows the previous state that I'm going to explain later, it will compare those two states and give me a preview of what's about to happen now. It says there is a new file, one file is going to be deleted, and then one file is updated with tags. If I want more details, I can say details, and then I see like prod is changing to staging. I'm happy again, so yes. Now it goes ahead and deploys the changes to the website. Finally, that was my development environment, so that I wouldn't forget to delete this after I'm going home. I can type Pulumi destroy, and that basically compares current state with empty target state and figures out how to delete everything. And in Azure, it's usually relatively simple with resource groups, but in AWS, to clean up everything up for yourself that you clicked in the portal, it's a nightmare. So this is a very handy thing. So that's the main workflow, how you work with this tool. Any questions about the workflow itself? Okay. Then back to the slides. So how else can this be useful, apart from IDE support and so on? So let's say my favorite Azure functions, I want to deploy Hello World application, HTTP or queue processing, whatnot. To deploy just a couple of lines of JavaScript, I have to deploy 5 resources to Azure. So function app, consumption plan, storage account, storage container, and the file with binaries. And actually resource group, so 6 resources. With C# I can solve this once, or sort of do it once, take the pain, create a component that would abstract these things away for me, and then start reusing that component as a simple thing that helps streamline my experience. So I already created such a component with TypeScript. We actually ship it with a standard library. Maybe we'll do it for C#. But the component, it's like a resource, virtual resource, which creates other resources inside of it. You can make nice grouping and reusing out of it. So I created a component. It's called archive function app, arbitrary name, because it just gets an archive of binaries to deploy. And then to deploy my function app, I just need 4 lines of code. I say what kind of resource group I deploy it to, and then just a path on my disk, and then it will go ahead and create all those 5 resources for me because I'm using a component. In the preview, that's going to look like this. So you get a stack, top level, then you see that component, and then under that component 5 resources that are going to be created. If I use component twice, I get this twice, and so on and so forth. The cool thing is that I can make this component as simple or as sophisticated as I want to. So, simple example, if I want to deploy JavaScript functions instead of C# functions, I can add an extra parameter runtime node. And by default, because I'm in C#, it's sort of assumed I want to deploy C# functions. But if I want to override with runtime. And then it will set the proper app setting or not in the function app. Next level of complication, if I want to deploy Python functions, I have to deploy them on Linux and also on a separate resource group. So I can create those resource group and Linux plan separately outside of the component, and then pass this created plan as another parameter to my component. So you can imagine the component is like, there is an if statement. If you passed it in, just take that one. If you didn't pass anything, then create a new one. So you can make the component as sophisticated as possible, but the usage is hopefully as simple as possible for yourself, for your teammates, or like open source community. A slightly more sophisticated example. Let's say I work in e-commerce company, like I'm competing with Amazon, and I have customers all over the world, so I have to distribute my application to like deploy it close to the customer, to keep the latency minimal, and all of that great stuff. So my deployment might look something like this. I'm using Cosmos DB to replicate data between multiple regions. Then That works great out of the box, but then if I'm using Azure Functions still, they only work in one region. So I have to deploy Azure Function to West Europe, and then it's only West Europe. So I have to deploy n copies of Function app, and then use something like Traffic Manager or Front Door in front of it as a router to guide the user to the nearest location. I have to do all the configuration, all the link of them, and so you can see how it gets quite complicated if I have to manage 5 regions and keep them sort of in sync, but slightly different. And then maybe I'm working on a product page, and another team works on a shopping cart or whatnot, and they have the same challenge with customers that are everywhere, but they don't use functions. They use, say, container instances. And they deploy it in 5 regions as well. And then there is a team which does, I don't know, G2E applications that only run on virtual machines. So they have to deploy VNets, subnets, public IPs, VM scale sets, scaling rules, whatever, and do it 5 times in every region. So we have things in common, and we have things that are different, right? We can sit down together and say that's going to be our component in this case. It's going to do all the Cosmos stuff, all the load balances stuff, and then it's going to have a pluggable application component that everybody can fill to their own needs. And once this is done, my usage of that component can be like this. So I, again, create a new object, pass a name, a resource group, and then a list of locations where I want to deploy. 3 locations, 5 locations, doesn't matter. And then it's just C#, so I can create like a callback factory method, which gets parameters from global deployment, from local deployment, and then bootstraps my infrastructure in just one region. So component will iterate for every region and call it 3 times in this case, creating 3 function apps, but I just write one snippet of code. And then I return the endpoint of that function app so that it could be hooked up to the traffic manager. And then we can ship this component to our private NuGet repository or to public one, and then version it with semver, sort of use all the best practices for the code, but apply them to infrastructure. Finally, a little bit more about how this works. So I hope you get the idea of what's possible now. How does it work? First, the challenge that we have multiple providers, 40, 50, it doesn't matter. We have multiple runtimes, currently 4, maybe next day 5, next year 6. So if we want to support AWS, we need to do it 5 times or 4 times currently, then do it for every provider. So that doesn't scale very well. So instead of doing this sort of thing, we have an intermediate representation of every provider, unified one. So we define it once, and then we have code generation that takes this model and generates all the language-specific stuff. So if you go to our GitHub.NET SDK, you will see in the header like this is auto-generated. Please don't change it manually, otherwise it's going to be recreated next time we run it. If you want to fix something, you go, or add some feature, you go to that thing, change that one, and then the next generation will sort of update everyone. I think we have like several million lines of C# generated from that, so it's not possible to write it manually. So what is this internal representation? Well, we have real internal representation, but also we can plug other things into it. Most popular case at the moment is Terraform. So we can take any Terraform provider and make it a Pulumi provider, and that's how it works for major cloud providers at the moment. The second popular use case is Open API spec. So Kubernetes has great Open API spec. It's always up to date, always truthful. When they release a new version, the same day we just code gen from it, and we have support the same day for the latest Kubernetes version. The day Terraform releases something that we have support, but if Terraform doesn't support a feature in Azure, then there are ways around it, but you don't get this support automatically. But the good news is because you are in C#, you can like work around it with just calling C# SDK. You can work around with ARM templates. We have a resource called ARM template, and then you pass JSON, and then it's deployed with the same life cycle. You can shell out to CLI. So with language, it's easier to work around things if you miss something. But like 95% is already there. Now to the state point. So that picture again, the same picture on the right. What is that state? So we store state ourselves. Because we work with all those providers, we cannot just store state in 40 places at the same time and then reconcile it every time. State is just a JSON file. It describes a graph of resources last time you deploy it. Well, it's a bit more complicated, but more or less. By default, it's going to be stored in our backend service. So when you use Pulumi app, you will send that JSON file to us, and well, in real life, you will never see it. You will never touch it. It's just internal implementation detail. If you, to some reason, like compliance or security or whatever, don't want to send it to us, you can put it on your local disk. You can. There are very common scenarios like S3 blob storage. You configure the CLI tool to put the state file there, and then it's your responsibility to manage it. If you delete it, then okay, you're screwed. But then we don't have access to your deployments and so on and so forth. Of course, if you deploy something with Pulumi and then your colleague goes to the portal and changes something, they can get out of sync. So, well, first they shouldn't do this for many reasons, but there is a way to reconcile them. So in Pulumi, you can say Pulumi refresh, and then we actually go to all those providers and check the state of resources. That takes time, so we don't do this automatically every time you do something. But so you kind of have to guess that somebody changed something and go, or do it in your CI/CD pipeline explicitly. Some people do it like if refresh returns something, then just fail and go figure out what happened. But refresh will show you a preview like the one I showed before of differences between Azure state and our state. And then it's your decision what you actually want to do. Do you want to update your Pulumi state with actual state, or maybe you actually want to update back the resources from our state to like cancel that naughty guy's changes in the portal. So there is this a bit of like extra complexity with state. Usually you don't really touch it unless you manage it yourself. But it's more powerful, and we actually store more metadata than Azure has, so it's more complicated. To reiterate, like what are the components? The CLI that I showed you, the Pulumi app thing, command line interface, that's a smart thing that knows how to compare graphs and figure out the algorithms. And providers, Azure provider, AWS provider, and so on. Both of these are open source. You can contribute, you can open issues, you can open pull requests. We accept every good pull request, what we think is good. Unfortunately for you, .NET developers, it's all written in Go. So Go is apparently the language for cloud these days, so everything is in Go. It's also cross-platform, works everywhere. The third component is that backend that stores the state, but that's also sort of like GitHub for your Git. It shows, or Azure portal for your ARM templates. It shows like the history of your deployments. You can navigate, see the graphical representations of tree, click on them to get to the portal. You can configure permissions if you work in teams, some policies, and so on and so forth. So more like enterprise features, working in teams kind of thing. And that is not open source, and it's free for personal usage, but not for teams. So that's how we make money. It's optional if you don't need it. Fine, use the free tools. We are absolutely fine with that. User base is more important than some bucks per month at the moment. But if you find value, then you will pay for this. Also, you can install this backend on your own on-premise enterprise environment if you want to, or in your own Azure or AWS deployment. So that again, nobody can touch it, but then you have it under the control, and again, you make sure that it's up and running. But that also costs money. A bit about security authentication. We never get credentials, so the machine, well, the backend service, The machine which runs CLI has to have credentials, obviously, because it talks to the providers in the end. If you are just a development laptop like I am, you type easy login and then we will reuse all the tokens. If you are in more like CI/CD pipeline, that's usually environment variables, pipeline variables, so on and so forth. Secrets, we also have secret management. There is no slide for that. But like Henry alluded to, some things you don't want to appear in the logs or in that state. So if you mark something as a secret, either input parameter or actually anything in the program, like you can mark any string as a secret, and then it will never appear in the logs, and in the state it's going to be encrypted with a key from your private key, or you can store it in Key Vault or anywhere else. So the state will not expose your sensitive information. Deployment usually looks like this. If you are a developer, you have your own account. You can screw it up if you want to, so you have direct access. You type, you iterate. When you're happy, you commit this to source control, and then hopefully you don't have access to production or read-only access or break the glass, all that good stuff. And then CI/CD pipeline runs it, maybe runs test, ephemeric environment, spins up, spins down. And in the end, it deploys to production with, we have plugins for most popular CI/CD tools like Azure DevOps. It's just a task in Azure DevOps. But in the end, it would call Pulumi CLI somewhere inside of it. Final example. Yes. Anybody using Kubernetes? 1, 2, 3 people. OK. But that's also an example of how the more complicated Pulumi program can look like, because Kubernetes is complicated. So if you need to run something on Kubernetes, you have multiple layers to manage. You need some storage, network, and that kind of thing. Then your AKS cluster or EKS cluster or some other managed cluster. Then you probably use some other managed services from the cloud. And finally, many developers can deploy their applications to the cluster. So the good news is that we can manage all these layers from Pulumi programs, but probably from different programs that might be created by different people, more IT people, more application people, at different point in time. So we have sort of a hierarchy of deployments. Organization is like a company, but then there can be multiple projects. So in this case, it's going to be an infrastructure project, AKS project, application project. And stacks are like environments: production, staging, testing. So you might have a matrix of infrastructure in 3 environments and like all of those. And the way you talk to them, to make them talk to each other, is that one exports outputs and the other gets outputs from the first one. Pretty similar to what ARM does, or actually Terraform or whatnot. So I'll quickly demo this without specifics of Kubernetes because no time. Right. I have a solution with several projects, but let's say 2 projects for simplicity. First is cluster stack. What? No passwords. Please. What's that? Go away. So I have a stack which deploys on the infrastructure, including AKS. Again, it's a stack. It has one output variable, kubeconfig. That's like a connection string for Kubernetes. And then resource groups, SSH keys, Azure AD, service principals, VNets, subnets, whatever. And finally, AKS cluster. When I deploy that, in the end, I'll get kubeconfig. That's my output of that stack. And then there is another stack, the application one. It starts by creating an object called stack reference that points to that infra stack that I just created. And then it says require output called kubeconfig. Require means it will fail with exception if it doesn't exist. And then it constructs connection string and then starts deploying objects to Kubernetes. And I just show this thing. That's an example. Oh, nothing works because of that security thing. So that's an example of a component resource that I was explaining before. So it's derived from component resource, a class with constructor. It has a name that you will see in the CLI output. And then it does all the smart stuff about Kubernetes. It actually makes deployment object and service object together in one component. So a lot of code in the component, but application code is very simple. You can sort of read it. This is a Docker image that deployed on port 80 with load balancing. Okay, so that's just an example of a more complicated. You can imagine you can have 15 stacks in your organization pointed to each other, and one pipeline or 5 pipelines triggered from each other, whatever you want. Finally, some FSharp. Yes, yes.
These files that you just showed, they're in the same C# solution or project?
This was same solution but different projects.
Okay. Can you also reference stuff from other solutions if they're in the same Pulumi accounts?
Sure, yeah. The reference doesn't care if it's in the same solution. It goes to the backend to get that state from the previous state deployment.
And you have identity and access management.
Yes.
Thank you.
It's killing me. So FSharp stuff. Just any FSharp developers here? Just one? Just one? Yes, yes. I'm trying to convert some people. So the basic point is that because it's .NET Core SDK, right? I can use any language from the .NET Core. FSharp, VB, PowerShell. It's the same SDK. FSharp code would look like this. So indentations instead of curly braces, but you can sort of read it even without using FSharp. There are some, FSharp is more verbose, a more explicit language, so we have a lot of implicit conversions in C#. And in FSharp we have to sort of use those helper functions, input IO and so on, that we provided, because it doesn't allow implicit conversions. That's a feature. But also FSharp is potentially very good to describe DSLs. It's quite a powerful language. So we have a prototype which doesn't work, but you maybe not care that much. There is an issue for this. This is also FSharp. But it uses computation expressions, sort of magic, monad-based magic, to describe a language. Because when you start, let's say, deployment in Kubernetes, there are 6 layers of what you need to define to deploy something in Kubernetes. And then when you write it this style, it sort of goes to the right quite quickly. And in this style, it sort of looks like JSON again, right? So people are very familiar with this JSON or YAML, it doesn't matter. But this is still strongly typed, compiled. You can do nice things like collection manipulation and so on and so forth. So it's sort of a combination. But for that, we would require to create an SDK specific to language. And another candidate would be PowerShell, because you can use PowerShell, but that's calling C# objects from PowerShell, not commandlets. We could generate commandlets, but that's maybe in the future. To look a little bit of how to keep this under control. So sometimes people say, especially operations people, if we give this to our developers, they're going to do horrible stuff with all those loops and everything. It's just too powerful. They will shoot themselves into the foot. And I don't know. I'm not going to do this. But I think a better answer is to provide them tools to make quality work, and then put some guardrails around what they can and cannot do. And there are multiple layers to do that. First, the developers themselves can now write unit tests, so what we are used to as developers. So it's just a unit test, X unit or something. Instead of calling deployment run, I call deployment test and then pass my stack. And that doesn't deploy anything, but just returns back the list of resources that it's about to create, or about, well, they are defined. And then I can navigate, that's just C#, so I can like ask for a specific type, a security group in AWS, and if I find one, then go through CIDR blocks, find an SSH port. If there is a publicly open SSH port, my unit test would fail. So I don't really know what's inside the stack. Well, I guess there is a security group, but I don't know the shape of my stack. But I can evaluate rules, and you can do whatever you can imagine here. Well, you can only inspect what you defined, because those resources don't exist yet, so you cannot inspect like URL of a website in S3. It's not a website in S3 yet. You can inspect mostly the shape of your inputs, but still it's quite powerful. You can imply rules on your code in many ways. In the next layer, so Henry showed policy as JSON. You can do policy as code as well. Unfortunately, C# doesn't work there yet, so that's TypeScript. Eventually it will, but I don't know when. But that's probably done by different people anyway, so somebody like security officer or IT people. And then they can write sort of the same unit tests or do some checks for resources. But then this is deployed to your CI/CD pipeline or to the backend. You configure which stacks are required to comply. You do it once, and then every time somebody does the deployment before creating resource, this is called. It has all the data now, or even website URL if it was created before. And then it can fail, and then deployment stops, and you get a notification in your web application or webhook or whatever. And then you can make it mandatory, so it will fail, or like advisory, so it will just log this and still allow deployment. So instead of writing 100 lines of JSON, you can write plenty complicated checks in TypeScript.
Are these executed in your engine or in the target platform?
It's executed in our language. So Azure policy has nothing to do with this. You have to enforce it either yourself, like in CI/CD, point to this policy pack, or if you use our backend, you can like click, and then enforce everywhere. But that's sort of, it doesn't cancel the need for policies, honestly. Like you might still want to implement both, like more like choose the right tool for your job and you cannot like generate JSON from this or that sort of things. So wrapping up, out of time probably already. Conclusions. First, agreed with Henry, don't click in the portal. If you do any kind of production applications in Azure or any other cloud, please use a tool for infrastructure as code. ARM templates, fine. If you're happy with them, perfect. Terraform, CloudFormation, Pulumi, anything. Anything is better than Portal. What I think we see in the industry is that over time we move from bigger components like hardware machines, virtual machines, to like containers, serverless functions. So it's getting smaller and smaller, more managed services. So the environments become more complicated with more components to manage. So this requires better and better automation. Maybe ARM templates were fine 5 years ago. They might be not fine now for things like serverless or Kubernetes. And then the new tools pop up, and then it gets easier to manage those components, so we get more and more of them again. That's like a loop. So I think the tools that are going to exist in the future probably will be different from what we have now. Exciting space to watch and be part of. And why I think real code is great, because developers start managing their infrastructure, so they want to reuse their skills, come prepared with your C# knowledge or whatnot. You get all the conditional loops not as an extra addition from the vendor, but just out of the language. And the biggest one to me is the ability to create abstractions. So if you do common resources together, you can pack them together as a component and then keep reusing that within a team, within your company, or worldwide, anywhere. Somebody in AWS said that we go from infrastructure as code to architecture as code. And the idea is that when you draw a diagram, boxes and arrows of architecture, you don't draw all those security groups and ingress rules and so on and so forth. You map out your application on a high level of abstraction. And now you can create components that would map sort of one-to-one to that diagram. And then your code would have the same sort of structure that you're thinking on. And that's easier to organize and keep it manageable and so on. So one advertisement, we have a workshop in Amsterdam on 30th of March. That's the day before KubeCon. You don't have to go to KubeCon to go there, but that's sort of to attract more people. If you're interested in sitting down for 4 hours and coding in Pulumi, that's a good place to go. And then you don't have to take a picture of that one if you don't care about the dates, because I have a like a link with all the links. If you just remember that link, you will get how to get started. Well, first you get to the slides, but also Pulumi site, some examples of how you use it in Azure or AWS. That workshop link is the 5th one. If you start using it, the best place to start to ask questions is Pulumi Slack, open Slack. There are like 2,000 people there. And then there are 2 blog posts. One is actually on .NET, Microsoft.NET blog, how you can use Pulumi C# SDK for Azure. And the second one is sort of like my component Cosmos app on Microsoft Azure blog. Coincidentally, I wrote it, but that's fine. Just to illustrate that we are challenging ARM templates, sort of, but overall we help people deploy stuff to Azure. So Microsoft is happy to promote us, to help promote them, and like get more money in the end. They don't care that much about ARM templates; they care about money. So with this, thank you for staying so long, and then questions if you want to